Every galaxy has one. Ours, too. Right now. Somewhere behind all those stars you can see on a clear night, there's something sitting at the center of the Milky Way that has swallowed the light of millions of suns and given nothing back. Not most galaxies. Every galaxy big enough to matter has one. It's been there this whole time, the entire time you've been alive, quietly at the middle of everything. And you've never seen it. You never will. Not directly. It won't let you. Now, here's the first thing your intuition gets wrong, and it starts with the name. Black hole. A hole. That word does you a disservice, because it makes you picture a gap, an absence, something missing. But this is the opposite of missing. This is the most concentrated, most present thing physics knows how to describe. Mass packed so tight, so dense, that space itself just gives up. We named this thing before we understood it, and now the name is stuck, and it's been quietly misleading people ever since. It's not a hole. It's too much of something, not too little. So what is actually happening? Let's build it from something you already know. Every massive object bends the space around it a little. That's just gravity. That's what gravity is in Einstein's picture. Stars do it, planets do it, you do it, technically, though the bend is so small it doesn't matter. Now here's the game. What happens if you keep packing more and more mass into a smaller and smaller space? The bending gets steeper and steeper. Picture a bowling ball on a stretched rubber sheet. You've probably seen that demonstration. Normal mass makes a normal dip, but now imagine cramming that same bowling ball's mass down into the size of a marble. The sheet doesn't just dip anymore, it plunges. It curves so steep, so fast, that it stops looking like a valley and starts looking like a cliff with no bottom. Now push it one step further, and this is where it stops being geometry and starts being frightening. Light is the fastest thing there is. Nothing outruns light. But if you bend space steeply enough, even light can't climb back out. And here's the part people get wrong. It's not because something is blocking the light. There's no wall. There's no barrier. It's that there is no longer an out to climb toward. The space that would lead away from the black hole has been bent back on itself so completely that every direction, even the direction that used to mean escape, now points back in. That boundary, the point of no return, we call it the event horizon. And once you're past it, away isn't a direction that exists anymore. So, obvious question. How do you take a picture of something that eats every photon that gets near it? You can't photograph darkness against darkness. Astronomers had to get clever. In 2019, the Event Horizon Telescope didn't photograph the black hole itself. Nobody's ever done that. Nobody ever will. What they photographed was the ring of superheated gas swirling just outside it. Gas glowing white hot as it spirals in, with one perfect black circle punched into the middle where the gas simply disappears. That black circle in the famous image isn't the black hole. It's the shape of its absence. It's a silhouette. We've only ever seen the outline of the thing, never the thing. And here's where I have to be honest with you, because this is the part that actually matters most. Follow the math of general relativity all the way down to the very center, and it tells you all that mass collapses into a single point. Zero size, infinite density, a singularity. Now I want you to notice something about that word infinite, because people hear it and think, wow, that's a real answer, that's how extreme it is. It isn't. Infinite is not a measurement. Nobody has ever measured infinite anything, anywhere, in any experiment, ever. When your equations spit out infinity, that's not nature showing off. That's the math waving a little flag that says, I don't know what happens here anymore. It's a breakdown, not a discovery. Something is missing from the picture. We don't have the theory that tells us what's really going on in that last tiniest fraction of a millimeter. Quantum mechanics and gravity are both trying to talk at once down there. And right now, they don't speak the same language. That gap, that's real. That's not me being dramatic. That's the actual, current, unsolved state of physics. Now, just when you got this pictured as purely a destroyer, a cosmic drain, something that only takes, flip the whole thing over, because here's the part that genuinely surprised the people who study this. These same monsters, sitting at the center of galaxies, appear to regulate the galaxies around them. Their gravity and even more strangely, prayer, the huge blasts of energy they throw off when they're actively feeding, can switch star formation on or shut it off across 100,000 light years. That's not a local effect. That's a black hole at the center of a galaxy somehow conducting the growth of the entire structure around it. Stars it will never touch, light years it will never reach directly. The thing that swallows light also appears to be, in some strange, indirect, still not fully understood way, a gardener. Astronomers call this feedback, and I'll tell you straight, nobody has the whole mechanism nailed down, but it's in the data. Galaxy after galaxy, the black hole's mass and the galaxy's mass seem to grow together in step, like the two of them are having a conversation we can't quite translate yet. So sit with that for a second. Every galaxy that got organized, spiral arms, star nurseries, all that light you can actually see and photograph and love, seems to have needed at its very center this thing that does the opposite of all of that. Dark, silent, consuming. Not a flaw in the design, part of it. The structure doesn't happen despite the darkness at the middle. It happens, somehow, because of it. And that's the thought I can't quite shake. And I don't think you should be able to either. Maybe that's not just true of galaxies. Maybe that's just true of things that grow into something worth looking at. That somewhere at the center, there has to be a place that stays dark. A place that takes more than it gives back. A place you can never quite look into, no matter how good your telescope gets, no matter how far you push the mathematics. And instead of that being some flaw, some failure of understanding, maybe that's what's holding the whole beautiful thing together in the first place.